It's like being on Zoom, but in person.
Yeah, you can't escape.
Okay, I'm gonna have a real demo here. Hopefully nothing weird happens while I'm doing mine. You in person didn't see that, so you're very fortunate. Let's see if my thing is gonna work here. Ooh, this is, maybe watch the video later to see the better quality. Jeez, this is like, I can count the pixels. It's like 8-bit slides here. So I'm Tim Spann. I run this meetup in New Jersey, New York, and Philly, and virtually, which is usually what we do. We're trying to do some in-persons. Thanks to the Pinot people for coming out. My demo is going to show NiFi, Pulsar, and Pinot and superset together. And all that code's in a GitHub. Let me see if my thing works. Oh, it does work. See, we're all friends here. You know, you mentioned those people who cannot be named. No, we know Kafka exists. We support Kafka too, but you know, we started a little after Kafka, so we run a little different, but we work with everybody. So we have a pretty good demo here. Has anyone heard of Pulsar before? A little bit. Have you heard of Kafka? Think Kafka, but the new guys who support a little different stuff. I'm not going to do too many slides. I'll go into the demos because the quality of the screen here is. I should have just brought Pac-Man. This is like, people at home are like, "What are you talking about?" It's crystal clear. In person, it's a little rough. It's like Pac-Man, maybe Pac-Man. I don't know. Let's see here.
We're in Spain. VGA.
I don't know that it's VGA, man. I mean, I can count the pixels. They're like little squares. So we'll go through that. We also have a chart of stuff we've been doing. I think we have more Slack people. We're really big in China, where they adopted Pulsar first through Yahoo Japan. Yahoo Japan is a massive user of Pulsar. Pulsar was created at Yahoo because they wanted to do what Kafka did, but they also wanted to do different types of messaging, and they didn't want to have two messaging systems because at the time Yahoo had Kafka, they had ActiveMQ, they had RabbitMQ, they had some JMS, they had MQTT, and it would be nice to have one messaging system that could do everything. So that's why they developed Pulsar, and then they open sourced it a couple of years later. We've got a lot of contributors, a lot of people on the Slacks, extremely active. We're more active than Kafka is now, as we keep expanding out, adding more features that people want. Native support for a lot of different protocols, all the things that you have to feed Pinot at scale. You know, one place to do it, doesn't matter if it's Kafka protocol, MQTT, AMQP, Pulsar native protocol, WebSockets, REST, you know, tons of different libraries. We make sure you get your message. And besides guaranteeing it, the way we store messages is with a ledger-based storage system, which is a little more advanced than just putting in one big file. So it guarantees you don't lose messages and you don't have to read them or acknowledge them in any particular order. So you can go back, you can do partials, kind of nice, very resilient. It's designed to survive multiple nodes going down without losing data, without losing the ability to write. And when you add more nodes, they automatically get used. You don't have to do a rebalancing. You don't have to wait until something catches up. It automatically stripes across all of them, a little bit like the way Hadoop works. And scalable as you need to be. It's used by Flipkart and Tencent for real-time gaming, real-time financial transactions. The scale is massive, usually combined with something like Flink. So you do something like an in-memory database. So they'll do things like a real-time cloud warehouse that's got 10 petabytes, and that's all real-time in RAM. Obviously, you got to have some money to do all that in RAM. But if you're poor, you can all run this on a laptop and still have everything. Pulsar, does all your broker stuff like you would expect how Kafka works, but we took the storage out of there. So if you have a lot of people want to read messages, but they don't all need to store things, makes it very easy to scale up the people accessing the data versus who's storing it. And Bookkeeper being a ledger-based data store makes it a lot better for designing, fast storage. So if we lose 2 nodes, I'm still striping out 3 copies of the data in a ledger system. So when I add a new storage thing, it just stripes across. I don't have to rebalance. I don't have to go offline because I'm missing my storage. Obviously, storage is more expensive than just a bit of compute, because the compute nodes can be pretty lightweight. They don't need SSD. You put your SSD in the Bookkeeper, and then at some point you say, I can't afford to have everything in SSD nodes. We have built-in tiered storage. So based on time, size, or some other magic attribute you come up with, it'll tier it out to storage. And that could be S3, that could be ADLS2, that could be HDFS, whatever makes sense there. It's an open API. People like Aerospike or someone else might add their own. Pretty easy to do. And what's nice is when it's federated out, you don't have to use some other tool to get the data. It just acts as if it was in Pulsar. Nothing changes. We use metadata somewhere else. If you're in Kubernetes, put it in etcd. If you're in the Hadoop world or don't care, you put in Zookeeper. If you're a really tiny one, put in RocksDB. Again, an open API, so you could use whatever you want for that. We're adding more storage systems. To support having multiple messaging systems in one platform, we got to be multi-tenant. So you set up a cluster or a federation of clusters, and underneath them, they have tenants of your naming, of your security. So there are companies out there that host Kafka by running a Pulsar cluster, and each person who buys it gets their own tenant. They're all secure, have their own security underneath, have all the features you want. Then you create as many namespaces under the topics as you want. And then under each namespace, you can create, generally recommend less than 10,000 topics per namespace, but you can go up to 100,000 per namespace. And we do have customers that have 1 million topics in a single cluster. And with them having their own tenants and namespaces makes them easier to find. You're not making a list of 1 million all at once. I wouldn't really want to sit on a command line looking at that or get that REST call. So that makes it nice to be able to have lots of different things going on. If you've done Kafka, you kind of get an idea what a message looks like. There's value, keys, and properties. We keep the producer name so we know who to blame if something's wrong. And we keep a sequence ID so we can make your messages in order. What's nice with Pulsar versus Kafka or anything else in the world, I'll take whatever protocol you got, you come in, it doesn't matter how you go out. So I could have MQTT in, comes into a Pulsar topic, comes out the other end as Kafka or Pulsar or MQTT or WebSockets, all at the same time, all can be concurrent. And this is impossible to read in the studio audience here, but we have different ways to consume your data. This is how you decide if you're going to do messaging or streaming. And this is per user. So I send data in, I could have someone decide down here that he wants to do a traditional messaging use case, which you would do with Rabbit or JMS, where I might want to do a work queue. I spin up 100,000 tiny little apps, each get a message, don't care the order, I just want to do work. They get that data that way. At the top, I do exclusive. They get all the data in order exactly once, just like Kafka, even using the Kafka protocol if you want. So you could do the streaming and the messaging on the same data concurrently without changing any systems and scale up to whatever size you want. Have as many of those as you want. We could also do one that's a little bit of both, key shared, where what you do is based on that key you have with the record, someone will just exclusively consume that one, and that'll be exactly once in order for you. So say you're doing CDC, every table, sign it a key. So you get to have 1,000 concurrent reads of those tables at once. And there's a couple that are in between, like failover. You got an exclusive reader, but if he's not working, have the backup take over. Couple different options. As you might imagine, we've got our own schema registry built in. What's nice is you don't have to do any extra work about it. If I produce a message, if I'm using Java, Python, or Go, just create a class that you're used to, send that in and say that's your schema, and we'll create a schema based on that. We support JSON, Avro, Protobuf. Again, extensible, put anyone you want in there. Versioning, you can access that through code. You can access that through API. You can access that through command line or any of the DevOps tools. Very easy to work with schemas. And we can play around with them if you need to talk to Kafka. We can use the Confluent schema registry when we're in Kafka mode if you need to. But again, that's built in for you. To get data in and out, obviously, I'll show you how to connect and have Pinot grab data as a stream from Pulsar. But we've got a ton of different ways to do that. We've got sources and sinks for everything. We support all the Kafka connectors. So you want to use the ones you have now for Kafka, just point them to us. But we have our own there that are native. We support, like I mentioned, a bunch of different protocols. We also support Rocket MQ, and there's a couple other ones that people are working on. We support processing with Flink, Spark, Trino natively, and I mentioned that tiered storage. We also have something to me that's kind of like a database trigger. We call these functions. These are stateless, lightweight stream processing. You deploy them with Pulsar, and it could either be running in a broker for you if you don't want to set up an infrastructure, or we have a Kubernetes-based environment you can just deploy them to. And this can be your own open source version of AWS Lambda, support for Java, Python, and Go. We've got a SQL language coming out next. Again, open API, and as opposed to some other projects, we let anyone commit as long as you are a good citizen in Apache. We don't have one vendor controlling everything, which is nice. We all work together pretty nicely. I wonder what that 8-bit message is. David, who is the person who wrote the Pulsar book, is on the chat answering some questions. We'll have, I'll give you the link at the end so you can get the PDF version of that book for free. So we got a lot of different ways to access your data. If you haven't noticed, there's some cats here. This is my cat. So we've got MQTT, I can access my data, Rabbit or ActiveMQ, Kafka or WebSockets. All those are very easy way to get your data in real time. And what's nice there is it's not a bolt-on, it's not a sidecar, it's not some kind of cache or little app that kind of makes a copy of the data. We have it so you could plug in a whole protocol stack. So it works the exact same way the Pulsar one does, which is really cool. So you don't have any kind of translation layer or any kind of nonsense there. Pretty straightforward. I mentioned those functions. We've got a connection to NiFi, and I'll show you why that's important. We have some very nice examples on how to connect Pulsar and Pinot. It works really nicely, so I'm going to show you that in a demo. All these slides are available, and I'll make sure you get them. I don't know if the people here can see this. This guy here. This is the link to the full free book. It is everything on Pulsar, full PDF. David's on the chat. When we get to questions, if the people in the room want to ask questions, I can put. David should be able to hear it, and he can answer them in the chat. Or he can join with voice if he wants to. We'll see how that works. I want to get to the demo because that I think is important. Then I'll give you the context stuff. Hopefully nothing important's come up on the chat. Oh, David's answering some cool questions, and we'll look at those when we get done with the demo. And again, this will be recorded once I edit out a Zoom bomb, unfortunately. Not sure how that got through. All the source code is available. I've got 2 examples. One is doing sensor data. I call that thermal machine because it's got a thermal camera on it. And I also did one for weather. This one is taking data. NiFi is grabbing all the weather in the United States, pushing it to Pulsar. Pinot's grabbing that feed super fast, as it comes in. And then I visualize it with Superset. Superset is a pretty awesome way to look at data. And I've got, oh man, I should have came up with some 8-bit dashboards. Who knew? It shows up a lot clearer on the screen. So we'll make sure everyone in person's got those later. But this is an example dashboard that you could do in Superset. And it's a really very easy way to connect to Pinot, which is very nice system because I could just do SQL connection right to it, query the data there. If my screen loads here, I've got one for thermal too, and you can put as much data as you want. Lots of different analytics you could do on your Pinot data. Man, it looks like people at home can't see, but in person, the video looks like, maybe they are seeing this over here. The video looks like it's, I have fake text up there. That's real text. It's real text. I know it doesn't look it. You can see the 52. It's a very low resolution. Maybe I can zoom in a little bit. Maybe that'll help. Kind of. So I've got a couple of tables that I set up in Pinot. If you haven't done Pinot before, it is pretty easy to build a real-time table. So I got an example of my data, and they've got a command line tool that converts that into a schema for you. I documented that in the GitHub. That loads it. Once you have the schema, you create a table on it, and then you can instantly start querying it. And it's super fast. This is all running on my laptop. So I've got all this presentation stuff going, a Pinot cluster, which is a bunch of different nodes of stuff, Superset. Plus I've got Apache NiFi running on here and a Pulsar cluster. And all this is running on the at the same time and still getting pretty fast results. This is some NiFi code that's taking that weather data, pushing it to Pulsar. Again, thanks to David, who's on the line, who wrote this connector. It is really easy. I point to the data coming in, say what type of data I want it coming out. So I could have JSON coming in. At some point I had XML. I converted it to JSON. I can convert it to Avro or Parquet or something. JSON's pretty easy to work with. And here I say send it to my topic. Pulsar is a little different because the topics work by having first word says persistent, because we could have non-persistent messages. If you've got something that's so fast, maybe some IoT use case where you're constantly sending, okay. Do I need to store that for a long time? Probably not. Turn off persistence. It only lives in memory for a short time. You could scale up on smaller nodes. David might be talking about that there. And then after that, I've got the tenant and the namespace and then my topic name. By default, built in is one called public. And then after that is default. Those map up when we're doing Flink right to a catalog for looking at these topics as if they were tables, but that's all it takes to stream in data into Pulsar from NiFi. And once it hit Pulsar, it is instantly available for Pulsar. So if I go to for Pinot, so if I go to my Pinot dashboard here and look at this weather data, I could take a look. You see it in there, and I'll look at the different columns here. And I could sort by the date I put on there. I've got a lot of fields. Let's sort by timestamp maybe. And we'll see which ones just fell. Anyone know what a timestamp is natively as today's time? Probably not. No, maybe somebody knows timestamp off the top of their head. Probably not. Let me look at what date field I have in here so we can see it as a time that makes a little more sense here. Now, these are all the airports in the country. Let's see, we want to do observation time, maybe. I don't know. Unique time. Too many fields here. Let's see. Maybe we'll do observation time just so you could see what actual time this is. I would make this smaller, but in person here, it's pretty rough here. Looking at this very pixelated format, we'll have to say something to the venue here because it's null. When I was first loading the data, I had some nulls. Okay, let's put in a where clause. So this is regular SQL. So this is nice that I don't have to do any kind of weird SQL here. This is just regular SQL. Like I didn't observation weather. What did I do here? See how easy it is, and then I'll mess up for nulls here. Time is null and weather is not null. How about that? Oh, I did something. I broke the internet here. Let's see what I did. Okay, I don't know what I'm doing. Okay, let's just order by observation time. But we can look, we got 58 documents scanned. I'll send more. Like I'll go to weather here. This is in NiFi. This is hard to see in this zoom out here, but can you guys see it in here? Yeah. A little pixelated. If you have any questions or want to see anything in depth, let me know. So I'm sending a bunch of data here. The way I do this is NiFi can grab any REST link. So it's grabbing back a zip file of XMLs. I unzip it, pull out all the XMLs, convert it to JSON, and then send, and each JSON has its own record to Pulsar. And I just sent that 5,000 there. So that's a pretty good chunk of data here. Let me see if I can get a refresh here. Let's see how many got loaded so far. Yeah, we got 1,000 loaded already. So it's loading this data. So we get a bunch of new fields here. Once it's in Pinot, then I can have it auto refresh in superset if I didn't lose my connection here. I might have put too much stress on a single Docker instance here that's running the Pinot server, broker, controller, zookeeper, superset, NiFi, and Pulsar, but I'm seeing some of it. And what's cool is you can see it as JSON if you wanted to do that. But any of the data, so Pulsar, NiFi to Pulsar to Pinot to superset, all on one box, no coding really. For set up a table in Pinot, it's some configuration. To query it from superset, I connect to my schema and then just build a dashboard, whether it's, and put in whatever kind of charts I want there. Lots of different charts you can build. It's a pretty cool tool there. And, you know, I could change ones that I have as long as I have some data. And live analytics, all of it open source, all of it pretty straightforward. I could show you more of that, but I want to look and see if we got any questions on the video. Maybe I'll zoom out a little bit because that's kind of brutal here looking at that. Let's see, where is my share here? Trying to find my window here. Let's bring those controls here. Oh, it's hiding it. Okay, there's a bunch in the chat. Let's see. I'll give everyone in person what he's saying here. Unless David, you want to join and talk for a minute or two. If there's anything that's super interesting. Schema registry is built in. It doesn't run as a separate node in the side like the Confluent schema registry. We got those different protocol handlers we mentioned. Yeah, and with the protocols, you enable the protocols you want. By default, the only one on is Pulsar. You flip a switch to say, yeah, I want to run WebSockets, I want to run Kafka, and turn that on. Obviously, having multiple protocols will require more resources because I'm running another set of things to process that. So if you're like, I'm never going to use Kafka, don't turn it on, that sort of thing. Yeah, etcd can be used in 2.10, 2.11. 2.11 is coming out soon. Yeah, we've gone a different way. Kafka decided to get rid of Zookeeper by putting that all into the broker node. So now you got one super node, but then those are really heavyweight. I don't know how you spin those up in Kubernetes easy and spin them up and down. Ours are very easy to add and remove. Oh yeah, Julian's awesome. See if there's anything new there. I didn't see any new questions there. Is there? Does anyone have any questions here? And also, we got a lot of pizza and soda left. You want to take it home? It's tough for me to carry all that home. So if you want that in the swag, does anyone have any questions? It's pretty easy stuff, you know, data in, put it on a screen, it turns into pixels, everyone enjoys it. Well, I'm not gonna keep people here an extra hour, this is not an exam. Thank you for coming. The video will be posted soon, I just have to edit out where there was a rude Zoom monitor in there. I don't think anyone wants to see that. So we'll fix that, then I'll get that posted in the meetup group so you can see the slides better. And the slides have already been posted. I'll make sure the link to that is there for everyone in the real world and in the virtual world gets those, and as well as the source code and other stuff. If you're someone who likes to be in person and are in the tri-state area, I will be in Princeton tomorrow at Tiger Labs across the street from Princeton University, which is a really nice town for Christmas. I'm hoping Cloudera will get some better food, but we'll see. If not, I'm definitely bringing some of those sodas over to Princeton. Come out if you can. We'll be doing more in depth on Flink and NiFi and some of the connections there. But if you have Pinot questions as well, definitely bring those. We should be recording that after the bombing. I'm going to have to check the Zoom for tomorrow's stream. So if you can't make it in person, they'll either be streamed or I'll record it to make sure we don't get any special guests dropping by. Thank you for coming in person. Thank you for coming on video. I don't know if you want to come, if you had anything you wanted to say, David, if you wanted to pop in or not. That's up to you.
No, I just wanted to.
Otherwise, they'll shut it down and post the video tomorrow.
Nope. Thanks, Tim. We appreciate everything. Glad to help. Thanks everyone for attending. Appreciate it.
Thanks, David, for blocking some of those. And I'm going to shut it down. It will be stored. And thanks for attending. Hope to see you tomorrow. It will be a different amount of information. Happy holidays. This is a one-of-a-kind shirt. If you want one, we could probably work something out. Thank you. And I'll see everyone tomorrow.
Thanks, Tim. Thanks, everyone.
Okay. That is all. Those people have questions, Brad, food and stuff.
Yeah, I have a question. What's the difference between your